watch it, turn it, see if it's not formatted, touch it, bring it, stay, watch it, turn it.
This is Mr. McCray coming to your way with another installment of Math Mentoring. Guys, in order to talk about it, we got to touch it, read it, learn it, and teach it. All right. In this segment, we're going over the homework where our focus was I can use my graphing calculator to explore the functions of a graph. So let's jump in, right? So, in question number 1, we're asked, on a set of axes, graph function absolute value x minus 3 plus 2. So, what ought to be done is, in our very first step, graphing calculators at the ready, we need to go into our Y editor. I'm just going to clear this out, 712. We need to go into our Y editor, and we need to put this function. For those who may have forgotten, the cheat code for absolute value is second catalog enter. And we're going to put that absolute value, minus 3, x minus 3 plus 2. Okay. The next step is we're going to evaluate the XY table, and we're looking for 1 minimum or max value and 2 to 4 mirror values. So what do I mean by that? So we can find our minimum or max value by just kind of analyzing this chart. And as I increase my X values, I see that my Y's are going down, going down, going down. And then at 2, they kind of plateau and they started increasing. So at 3 comma 2, I know that's my minimum value. Okay, so I want to select that point as my starting point. And then I want to get 2 to 4 mirror values. Sometimes I call them cousin values. And what that looks like is this. All right. If I am starting at 3 comma 2, I'm right about here. But then if I go 2 comma 3, 2 comma 3 is roughly right here. And if I do 1 comma 4, 1 comma 4 is roughly right here. If I do 4 comma 3, 4 comma 3 is roughly right here. And 5 comma 4 is roughly right here. All that leads me to an image that's very similar to this. And in fact, when you deal with absolute values, this is going to be the image that you ought to get if you've done the problem correctly. Let's move to the next problem. In the next problem, I'm asked, a relation is graphed on a set of axes to the right. Based on the graph, is the relation A a function because it passes the horizontal line test, a function because it passes the vertical line test, a function because it fails the horizontal line test, not a function, and not a function because it fails the vertical line test. Okay, so let's revert back to what we've talked about in the past. Okay, here's what you know. When analyzing graphs, use the vertical line test. We've talked about that a gazillion times. In that vertical line test, we are going to pass our relation through this vertical line, and if it only touches my vertical line but one time, it in fact passes the test. So good to go. Question 2. A function is defined as 0, 1, 2, 3, 5, 8, 7, 2. Give the domain and range of the function. Okay, well, that's not hard because we've done this before. We basically said when analyzing ordered pairs, look for repeating x values to determine its function. Okay, so not only can I tell you that the domain is these set of values, 0, 2, 5, 7, and the range are these set of values 1, 3, 8, 2, I can also tell you that this is a function because I don't see any repeating x values. All right, so that's a bonus because we weren't asked that question, but we're already there, so we might as well look at it. Next question. Is the relationship shown below a function? Explain your reasoning. Well, again, friends, we've worked with these domain range maps before, and the key is I'm looking for x values that match or pair to more than one y value. See, if I see an x value in this case and it's paired to more than one y value, then it's not a domain. It's not a function, excuse me. It's not a function. All right. Next question was, which point 4, 3 or 3, 4, if included, would make this table not a function? Explain your reasoning. Okay, we've looked at these problems as well. Okay. When analyzing ordered pairs, look for repeating x values to determine it's a function. If it's a function. So let's look at case 1. 4, 3. Okay. Any repeating x values? No, I don't see any. We would say this is good to go. This is a function. All right. Let's take a look at case 2. Well, case 2, we can't say that. In case 2, we see that we have 3 that's repeating. All right. And because of that, we will say case 2 is a violation. It doesn't pass the vertical, it doesn't pass the function test. Okay, let's go on. Final question, final 2 questions. Is the relationship shown in the table below a function? Again, looking at the table, what do you guys think? Do we see any repeating x's? No, we don't. So we have to conclude it's a function. Okay, final question. The student council sent its members on 4 field trips during the school year. The number of businesses needed to transport the members on each trip is a function of the number of members who went on each trip. This function consists of only the ordered pairs of 35, 4, 58, 7, 97, 8, and 109, 11. What is the domain of this situation? Justify your answer. All right. And hopefully, again, we've talked about this a little bit already. What are domains? Domains are the values in the x side of the table, XY table, and it's their first value in order pairs. So my domain would be 35, 58, 97, and 108. Answer that question. Bonus, is this a function? Do we see any repeating x values? If the answer is no, then it's actually a function. All right, gang. So, as always, Mr. McCray wants to encourage you, pause this video, internalize the skill. Remember, 30 minutes of study a day keeps bad grades away.